Okay, this video is about how I made a device to allow me to take really cold showers in the middle of the summer when the water was really warm from the city water supply. The water actually gets up to 85. It's about 75 now. But what to put in the middle to make this water chill down is the chill button. This is the finished product, and you can watch the temperature drop starting out at about 75 degrees Fahrenheit. And there's some water, it has to come through the pipes, and also some water there in that bin that needs to be chilled down. But basically, at the end of this clip, you'll see that the water temperature runs down to about 44 degrees Fahrenheit, knocking the temperature down 30 degrees from where it started. So how did I do this? Well, it started out with a water supply and ended up with cold water. That's cold in the summer, and you need a cold source of some type and a way to transfer the heat out of the water that's in the tap water. So you use a heat exchanger. And I was familiar with this from my brewing days, which is kind of the reason I put this together. So this is how a heat exchanger works from a flow standpoint. The cold source is on a loop, and then the tap water goes straight through and out the shower. So the two sources of water, they never mix. They just get close to each other and transfer the heat. So I went on to this site, which again I knew from my brewing days, and you could pick out all kinds of different heat exchangers. I basically just bought it by price. I wasn't willing to pay that much. So you basically, the more square meters, the more it costs. So I picked out a reasonable one. So now we got to figure out a cold source. So if you go to Craigslist and you just type in fridge, at least in my area, there's tons of these little dorm fridges that are on there, and a lot of times they go for about $40. And this one would work. There's another one on here that this one is on there for free. Just come and pick it up. So, and that one would work. I happen to have one already because I had kids in college. But even if you don't find one on Craigslist, you can always go to Sam's and get one for about $120. So yeah, they're readily available. So now we got our cold source nailed. Now that's just a small matter of plumbing to take care of. This next section, we basically lay out how the system will be installed. So in comes the cold water pipe, cold in quotes, and it goes to a shower, one shower down here. That's the basement shower. And that also continues on and goes to an entire another bathroom, and that's the master bath. And so the entire master bath will be affected, and just the shower in the basement will be affected. So basically, we got the cold water coming in here, and it goes to this valve, which goes either this way, which goes to both the shower downstairs as well as the master bath, or it goes this other way through the chiller. And you don't have to put this valve in. In fact, I wouldn't recommend it. But it goes through the chiller, and then it continues on. But I didn't know if there'd be a pressure drop through the heat exchanger, so I wanted to have the ability to flip. Anyway, the other circuit just goes out of the refrigerator and then back into the refrigerator after going through the heat exchanger. So I made kind of a layout with parts so that I could make a list for my curbside pickup at Home Depot, so I didn't have to go in. Got all this stuff thrown right in my trunk, which was great. And then I got this stuff from Amazon. I got the pump, a pond liner, and then that valve that you can switch to either go one way or the other way. And like I said, you don't need that. Just hard plumb the heat exchanger right into your existing plumbing is fine. So here's the heat exchanger, the plate chiller that I got from this dude at Diesel place. And the specs say that it's tested up to 330 psi, so it's plenty good for holding my city water pressure, which is about 100. And here's the flow diagram that's on the unit. So I started out with this refrigerator. This is a dorm fridge that one of my daughters used. And I used this temperature sensor to determine where the evaporator coils were, and this is where they were. And I thought, well, I guess I'll cut them out. So I basically used a saw, and I gently cut through the plastic, and then I pulled them out. I pulled the coils out. But you do not want to use a refrigerator like this, as it turns out, because the aluminum coils in there, although they held for the first test, like I had pulled them out and I had rearranged them so that they would be immersed in the water. And it chilled at that point, but by the time I got done installing the pump, and there's a lot of jiggling that goes on, the aluminum coils just didn't last. There was a leak developed, and then, of course, it didn't chill. So this is the way I kind of bent the coils, and like I said, at this point, the thing chilled, actually. But later on, a leak developed. So I had to substitute a different refrigerator. But I'm going to continue to show you this progression and then show you the new refrigerator that I put in there. So anyway, I got the pump, and also got the pond liner, so I'm kind of ready to proceed on the project. So the next step is to adapt the small refrigerator so that it can hold the volume of water inside the refrigerator. So the first step is to take away some of this plastic so that we can get down into the metal. And I have this piece of oak, so this is very strong wood, and it's cut such that it goes behind the metal on the sides. So I think it'll hold. You just kind of cram it in there. There's insulation in the way that you got to remove. But I think that this will probably be able to hold back the weight of the water. So I cut some more of these oak strips, and I cut them at a 45-degree angle so that they would slip in behind the wood. So I'm going to use 4 of them total to hold the water back, and I'm going to cut some plywood. I've cut some plywood for the back there. I think I showed that earlier. And here's the plywood for the front. So I'm going to have one lower piece here that covers the refrigerator door section, and then a smaller piece that goes above. But just slip these oak pieces in at an angle and then have them lock into place by going horizontal. So 3 of them on the bottom, and then there's going to be one to hold back the top. And the bar itself between the refrigerator and the freezer will hold back the bottom of this top little board. I want to get as much water in there as I could, so I'm going up close to the top. So now it's time to get the pond liner in there. And I could have just done it haphazardly, but I thought I'd try to fold it and kind of make this shows like a bottom and 3 sides, and this kind of shows the fold. It's kind of like a grocery bag fold that I tried to do, measured to the bottom of the refrigerator. So hopefully I've got this right, because I'm going to cut this off right here. And of course, if it's below the level of the water anywhere, it's going to leak. So here's the pond liner that's inserted into the refrigerator, and you can see that those tubes, those evaporator coil aluminum tubes, are getting jockeyed around quite a bit here, and I think that's probably when the leak was introduced. But I'm trying to get the bottom of the fold into the bottom of the refrigerator, and I think that's about right. And of course, when the water presses down on it, it's going to go where it's going to go, but I didn't want it to pull the liner down and be below where I intended it to be. So I thought, well, let's just set it down in And by weighting it down with some water, and I'll also test the ability for it to hold water. So I don't have the panels in yet here. I'm just going to put a little bit of water in, and then I put the panels in later and started filling it up more. And so I'm going to fill this thing all the way up to near the top, and the boards seem to be holding okay. And then I'll let it sit overnight, and then see the next day if it's holding all its water. So I stopped filling and removed the garden hose, and I'm going to let it sit overnight. So yeah, so the next day I came out, there was no leaks, and so I pumped it out and used the pump, the electric pump that I'll be using for recirculation. And then I started working on the refrigerator some more, drilled a few holes. One will be the inflow, the other outflow. Okay, we're going to take another look at folding the pond liner. This time I kind of drew a little diagram. That's kind of what I'd like to have it folded as, and took a piece of paper and tried to make a kind of a model of how I wanted it folded this time. And then I actually made a little cardboard thing to put it on so that I could visualize it. Because once you get this thing assembled, it's so floppy you don't know what's what. So I kind of folded it on the ground and then got it ready. So anyway, the next thing that happened was my threaded fittings for the valve were dripping. Very slowly, but of course you've got to fix them if it's dripping. So this time I put caps on it and I pumped it up to over 100 pounds and I let it sit, and it didn't leak. So I was ready to reinstall it. So here's the next refrigerator. What I did is I put some alcohol on the top of it and then turned the refrigerator on and took pictures of it as it warmed the top of the refrigerator. So I knew where these aren't evaporator coils. These are the heat reduction coils or whatever. So I figured that's the kind of the plan I wanted to go for. So I planned my penetrations through the top of the refrigerator, and if they're close enough to the front, I think they'll be out of the way of those coils. But I decided to be really careful, and so I cut only through the plastic, and then I used my hand to twist this circle cutting saw. And then I carefully took a screwdriver and plucked away at the insulation and made sure that there was nothing there that I would hit. Only then did I go ahead and drill it out. So I got the holes drilled. And then I wanted to put a piece of wood in there so it made it sort of a uniform. I didn't want that step back there to be pushing on the pond liner too much. The coils would rest against that. And I just put a single screw in there just so it wouldn't fall out when I was working with it. And you've seen this before in the previous refrigerator. We did this same technique by removing a little bit of the plastic and then digging out the insulation where needed in order to get these sticks to hold the piece of plywood in. That is eventually going to hold the water back from falling out. Got to remove a little bit of that insulation so you can get behind the metal. So I get my oak sticks behind that metal there. So anyway, here's the pond liner folded up and kind of shaped with that piece of cardboard to fit. And here's the pond liner stuck in there. And again, it's floppy and you don't kind of know where everything is. But once the water gets in there, it settles in. I just didn't want it to settle and pull the pond liner down. So then I got the piece of plywood. This is 1/4 inch, by the way. And these pieces of oak to hold the plywood into place. One of those has a tongue and groove that's a little bit weaker. I think all these are plenty strong for what I need them for, but I put the full ones on the bottom, and the ones that had the little tongue and groove notch out, I put them on the top because they're going to have, top ones are going to have less pressure on them. Notice the spacing too. The bottom ones are closer together. So there we have our fridge kind of ready to go into place, and I got it positioned underneath the inflow and outflow of the heat exchanger. And it's in a drip pan and sitting on the stand, and it's ready to go. Now I need to put the motor, drop the motor in there, the submersible pump. Kind of got a couple of the sticks out so that I can get the motor in there. Drop that down and then connect it with a piece of PVC. And these aren't pressure fittings, so these aren't very critical to get super tight. These are under very low pressure. Not like the house pressure, which is over 100 pounds sometimes, 85 usually. But we got the inflow and the outflow, and that one's just got an elbow on the bottom of it, as you saw. And here we are filling the water up. So we're going to take the pond liner and kind of pull it up and make sure that it's not sagging, and checking to see that the board is going to hold. And so the temperature down there is 80 degrees in the crawl space right now, and the water temperature here turns out to be about 76. So I put the door on and plugged in the refrigerator, and so it should start chilling. So if I plug in the pump here, we can hear it come on, and nothing interesting happens. The water's recirculating through the chiller. And then I plug it into the switch, and that has an air hose that's connected to inside the shower. That's how we turn on and off the pump. So it's 76, it started, and 5 hours later, it was down to 55, and eventually it gets down to 39, I think. So here we are at the end of our video. Put the chiller into action. And we're also going to review the parts that we bought, the big parts anyway. So, yeah, you saw this before. Water temperature on the cold side in my neck of the woods is 75 degrees. And it's going to get up to 85 before the summer is over. And so one of the parts we bought was this switch. It's an air switch. There's no electricity in it. So you push that button and the pump comes on. So it comes with these parts. And we also bought this pump, and that's what just turned on. It takes a minute for the water to come through. We'll be dropping shortly. And of course, to hold the water inside the refrigerator, we have to have a pond liner. Oh, it's dropping, and here's the refrigerator. And you might get one of these for $40. You might have to pay $120. Or you can get one for free, like I did, because my daughter had one at the one. And then this, you have to buy, and you might be able to get by with a smaller one, but I paid $111 for this. So, what did this cost me to get my water chilled? Well, it turns out for me, it was actually a little bit less, but for you, maybe $270. That's pretty reasonable for having a button you can press and get a really, really, really cold shower. So now the temperature's dropping, 44.7, 44.6. How's that for a nice chilled shower? So there you have it. Hope you enjoyed it. Okay, so you're still here. I thought I'd show you that you didn't need the valve. So basically what we've got here is a bucket, and we're going to time how long it takes to fill it up. It took about 42 seconds. And now we're going to change it so that it's direct flow. So it's not going through the chiller now. We're going to do the same thing over again. Bucket's full again, and 40 seconds. So maybe 2 seconds difference. It's just not worth it. There's no need to purchase the redirection valve. Just hard plumb your plate chiller into your system, into your house water, and you'll be good to go. Hope you'd enjoyed it.